Hey guys, so in this video I'm going to give an overview of what polynomials are and just like some really key things that you need to know when you work with them. I highly recommend that you pause and try the examples when prompted. And also there are free guided notes available at divideandconquermath.com that I think go really well with this particular section. So I kind of outline like a bunch of different exercises and stuff, so I highly recommend that you download them. They're totally free. Okay, so what is a polynomial anyways? So honestly, for the most part, you've already been working with them. It's just we're basically adding some extra vocabulary onto things that you've already been working with. So I find it's easier to show examples of what polynomials are versus what they are not before I just tell you the definition. So here are some examples. So I want you just to look at them for a second. So I've got like x squared minus 3x plus 8. I've got this x to the 7th minus 5x to the 4th plus 2x cubed plus x. I've got 9. I've even got like 7x plus pi or x cubed plus 2/3. So the thing that makes a polynomial is you can have any numbers that you want kind of here, but your exponents, these have to be positive whole numbers. So just to give you some examples of what's not a polynomial, so let me show you just a few examples. These are not. So something like the square root of x minus 4. This would not work. These here, so 4x to the negative 4th minus 7x to the negative 3rd, these are negative exponents, so these won't work. Also, this situation here, this would also not work as polynomials. So polynomials are something very specific, but like I said, most people have been working with them already by the time that they learn the vocabulary with them, that people don't even really think about, think twice about, this. So polynomial, just to make this nice and formal. This is an expression with real numbers, variables, and whole number exponents. And the thing that we like to do with polynomials is we put them in what we call descending order. So this is ordering a polynomial from the largest exponent to the smallest, and any freestanding number would come last. So this is where I want to start, because generally if you put a polynomial in descending order, it makes everything easier with the polynomial. So in this case, so just starting with this first one, so we're going to put these two polynomials in descending order. So all that matters here are the exponents. So as I look across all these exponents, this is the largest exponent, so it doesn't matter what number's in front, this is what's driving everything. So if I put this in descending order, this is going to equal 5x to the 8th, got rid of that one. The next smallest exponent will be the negative 2x to the 7th. Then we've got 4x to the 5th, x to the 3rd, and then 3x squared. So that would be the proper descending order. So maybe you just want to pause real quick and give B a try. So if I'm going through this one, I have negative x to the 6th minus x to the 5th plus x to the 4th minus x to the 3rd plus x squared. And then this is what I mean, this plus 3, that's like a freestanding number, so that'll come last. So we just want to make sure that we keep that in mind as we work with polynomials. So now we need to discuss just some other vocabulary, and I'm going to show you kind of what it all means as we go through it. So the first thing we're going to talk about is what is a term, and this is any part in a polynomial that is separated by the plus or the minus sign. So I'm going to use this polynomial just to explain this to you. So this polynomial here would have 3 terms. So it's anything separated by a plus or minus sign. So you can see that separation. So this would be the 3 terms. Next, we have variables. So these are the letters in a polynomial that represent numbers. So if I use the same example, so my variables would be this really just x. So it doesn't matter if they have exponents on them or not, just the only variable in this particular polynomial would be x. You can have more than one variable in a polynomial though. Okay, next up are coefficients. So these are the numbers that are attached to the variables. So this is a very important distinction. Using this example here, 2 and negative 4, those would be our coefficients. This 2 here is not attached to a variable, so it gets a different term. That 2 is what we would call a constant term. So this is the freestanding number within a polynomial not attached to a variable. So this right here, this would be our constant. So it's very important that you kind of know how to use this terminology just because it gets used a lot with polynomials. So I just wanted to take a second to just do a couple exercises where we talk about what are the terms, variables, coefficients, and constant terms, just to make sure that you've really absorbed this vocabulary. So let's start with this first one. So we're going to list all of these things. So the terms here for 2x plus 3, that would be 2x and 3. We've got two terms. The only variable here would be the x, and then we only have one coefficient, which would be 2, and the constant here would be 3. So that's what we're going to do in this exercise. So let's do another one. So now I've got 3x squared minus x plus 5. So maybe you just want to take a second to think about this before I write everything down. So the terms in this case would be 3x squared, the negative x, and the 5. If you didn't put a negative with the x, that we could kind of debate what makes it a term. But as long as you have three terms, you're good. The only variable here is the x in this case. The coefficients here would be 3. And then there's technically like this -1 in front of the x. I always put parentheses around this because we can't see it, but we know that it's there. So this is kind of how I like to represent. We can't see it, but we know it's there. And then the constant in this case would be 5. Okay, so what about now if I have this polynomial? So this is actually a polynomial, just having a number by itself. That's still counted to be a polynomial. So what are the terms in this case? This would be 5. Are there any variables? There are none. Are there any coefficients? There are none. This is just a polynomial of one term, and it's just the constant 5, but that still makes it a polynomial. All right, so I've got just one more example here. So at 2x squared y plus 3y minus x. So the terms in this case, I've got three terms. I've got 2x squared y, 3y, and negative x. And my variables in this case would be x and y. Now, the coefficients here would be 2, 3, and then once again we have like that -1 that we know is kind of there in the background. But this particular polynomial has no constant. And so that's totally fine. You don't have to have a constant. Like there's nothing about how many terms you have to have or variables or constant, no constant. Like anything kind of goes with polynomials. That the only thing that you really need are those whole number positive exponents. Okay, so moving on. Now let's talk about degree. So the degree of a term is the sum of the exponents of that term. So what we're going to do in this next exercise, just to help you understand what that means, is we're going to identify the degree. Now, in some cases, this is really simple. So like this first side here. So if you have just one term with one exponent, then the degree is just that exponent. So in this case, it would just be 4. So like here, the degree would be 4. Here with 3y to the 6. So the 3 has no impact on this. This is really just talking about the exponent. So the degree here would be 6. Now here with x, it has an invisible exponent of just 1. So this would be the degree of 1, which then leaves the curious case of what must the degree be of just a number? Well, if this has a degree of 1 and this has no x, then the degree of just a plain old constant, the degree of all constants is 0. So, like I said, pretty straightforward to determine the degree if you have just one letter. However, if you have two variables, like we see in this column, this gets just slightly more complicated. And this is where that idea of the sum of the exponents comes in. So for e here, I actually add both of these exponents, the 4 and the 3. So the total degree here is 7. Make sense? So this is just how we resolve this problem of what's the degree if we have more than one variable. So with f then, I'd have to add up the 7 and the 9. So this would be a degree of 16. And then for g here, so once again, so I'm just going to add everything up. So 4, 2, and 5. So that's going to come out to 11. And then finally for h, so x has an invisible 1, so the degree here will be 1 plus 4, so that is going to be equal to 5. And so that's how you find the degree of a term. Now, there's a similar vocabulary word now related to this. We have the degree of a term versus the degree of a polynomial. And the degree of a polynomial is the same as the degree of the term of highest degree within that polynomial. So I will show you some examples of what I mean in a second. The other thing I want to tell you about is what's known as the leading coefficients. The leading coefficient is the coefficient attached to the term of highest degree in a polynomial. So we'll take a look at that in a moment. And then just one other thing I want to state here about different types of polynomials. So we have more specific names for a polynomial with 3 terms. That's called a trinomial. A polynomial with 2 terms gets called a binomial. And then a polynomial with 1 term is called a monomial. And then a polynomial actually it has kind of 2 meanings. So it is a general term. So any one of these terms can be replaced with polynomial. I could just call a trinomial a polynomial. It's just not as specific, but a trinomial is a polynomial, or a binomial is a polynomial. So it does fall under that category. But you also use the word polynomial for any polynomial that has more than 3 terms. So it kind of has 2 different meanings. So if you have just 3 terms, you can be more specific and call it a trinomial. If you have 4 terms, then it's just a general polynomial. Okay, so now what I want to do here is I want to identify the degree of each polynomial, and then I want to find the leading coefficient, and then if we can, I want to describe the type of polynomial that we have. So let's start with this first example, and I want to kind of show you like the best way to really approach this. So we're trying to find the degree of the polynomial, but the one thing I want you to practice with this is to actually find the degree of each term. So we'll just go in order here. So the degree of this term, x to the 5th, would be 5. And then the degree of the next term, this 4x to the 3rd, the degree of this is 3. And then the degree of negative 2x, well, this has that invisible 1 exponent here, so that last degree would be 1. So what I want you to do is list out the degree of each term, just so you have a second to think about that. And then the degree of the polynomial is the highest degree that we have here. So in this case, it would be 5. Okay, so that's how you find the degree of a polynomial. And then the leading coefficient, so you find what term has that 5 attached to it. So this x to the 5th. So the number that is in front of this is your leading coefficient. So in this case for x to the 5th, I don't have an explicit number stated, but I know that the leading coefficient here would just be 1, right? Because we can omit it. So the leading coefficient here would be 1. And then this polynomial has 3 terms. So I'm also going to state that this is a trinomial. So that's how I want to practice this next set of vocabulary. Okay, so moving on to this next one, maybe you want to pause the video here and then hit play after you've had a second to think. So talking about the degree of each term, the degree of the first term is 2 and the degree of the second term is 1. So we've got 2 and we've got 1. Now, the highest degree that I see here is 2. And so then if I look for the leading coefficient, so this was where the degree of highest term was, and there's a negative 5 in front. So the leading coefficient in this case will be negative 5. And then there's only 2 terms here, so this will be a binomial. Okay, so now moving on to the next one. Once again, maybe you want to pause here and then hit play when you're ready. So the degree of each term in this case is 1, 4, and 2. So this time I actually went out of order because I didn't want you to think that, it's just going to be the first term always. So the highest degree that I see here is the 4. And then if I look at this x to the 4th, so this is 2x to the 4th, so the leading coefficient would be 2. And then we have 3 terms, so this would be a trinomial. Okay, so moving on to this next one. Again, if you're looking for practice, you can just pause here and then hit play when you're ready. So the degree of each term in this case will be 5, 7, and then the degree of negative 4 would be 0. So the degree of the polynomial will be 7. So if I look at this 2x to the 7th, there's that 2 right there. So the leading coefficient is 2, and there are 3 terms, so this is a trinomial. And now for just one last example here. So now I've just got the number 8. So the degree of this term would be 0. The degree of the polynomial is 0. There is no leading coefficient. and this would actually be considered a monomial in this case. So that's kind of how you work with the idea of degree. So the last thing that I want to talk about, or just kind of quickly address here, is how do you evaluate polynomials? And you evaluate polynomials just like you would, like you probably already have been with any other type of equation. So in this case, it says like evaluate the polynomial for x equals -2. So all this means is just to put in -2 into this expression. And then you just kind of evaluate like you always would. So if I just plug in -2, I just have to respect the order of operations. So -2 in parentheses squared, this will be 4 minus 6 plus 1, and so this will ultimately equal -1. And so that's all you really have to do when you're trying to evaluate polynomials. So if I want to look at just 2 more examples with this, so let's say I have something like evaluate the polynomial for x equals -2. So again, I plug in the -2. The only thing I want to remind you of is make sure you're using parentheses when you do this, because you are meant to square the entirety of that value. So that does require you to use parentheses, and that tends to be one place that throws people off. So for instance, in this case, I've got -2 cubed. So -2 times -2 times -2 will be -8. But -2 in parentheses squared, this value here will be 4. This becomes +4. And then I have to subtract that result off. Here I've got a negative times a negative, so this will be +6. And then we've got +4. And so now if I just go ahead and finish this off, so this becomes -12 plus 10. So this is going to equal -2. And I thought I'd just throw in one more here with a little bit of fraction practice. So still the same idea. So you don't always have to plug in -2. I just chose that value to plug into all of these polynomials, but you can be asked to put in any value that you want. So if I just plug in -2 here, so again, maybe you want to pause the video and actually try this on your own. So if I work this out, this is going to give me 1/4 times -8 minus 1/2 times 4 minus 10. And so this will come out to -2 minus 2 minus 10. So this will equal -14. And so that's just your entire quick overview of how to work with polynomials. So I have other videos where I'll talk about how to like add, subtract, multiply, divide, all that good stuff. This was just kind of a quick overview of some of the basic ideas associated with this and vocabulary. So thanks for watching, guys. I'll catch you next time.